Well, hello again. Here we are in 2.5, System of Inequalities. So how are we using systems of inequalities to find feasible regions? So at this point, hopefully we are going to understand that when we are working with systems of inequalities, we're not just going to have one number or one solution. We're not going to have infinite solutions, or we're not going to have no solutions. Well, we could have no solutions, but the solutions that we do get are going to be in a region. It's not just going to be one specific solution. So we are going to graph the linear inequality, and then we're going to list one point that is a solution and one point that is not a solution. So these first two are just given one linear inequality. So this is just a review. This is something that you should know how to do. Remember, we're not going to be seeing equal sign anymore. We're going to be seeing a greater than, equal to, less than or equal to, a greater than or a less than symbol. If we have a less than or equal to or greater than or equal to, those are going to be drawn with a solid line because we are including everything along that line. If it's less than or equal to, we will shade below. If it's greater than or equal to, we will shade above. If it's less than or greater than, we will be using a dashed line, and that means we will not include anything along that line in our solution set. And again, if it's less than, shading below, greater than, shading above. So like I said, the first two should be somewhat of a review. So I go ahead and I get started. I see that my slope is going to be a negative 1/3 and my y-intercept is a positive 2. So I plot that positive 2. I use that negative 1/3 slope. So that could be up 1, left 3, or down 1, right 3. And so then I can use that slope and that y-intercept to create a solid line here. This is going to be a solid line because we have a less than or equal to symbol here. And so because it's less than or equal to, at this point, I know I need to shade everything below that line. And so then the question says, list a point that is a solution and list a point that is not a solution. So a solution could be anything in the shaded region. It could be 0, 0. It could be negative 3, 1. It could be 3, negative 10, whatever. I'm going to go with origin, 0, 0. Something that is not a solution is obviously not going to be on the line because this is a solid line, and not in the shaded region. So anything in the white area, and I'm going to go with the points. Let's go with 5, 5. So obviously there are going to be multiple correct answers for things that are solutions and multiple correct answers for things that are not solutions. Remember, in the solution, we could also include anything on that line. So if I wanted to put 0, 2, I could use that point because it is less than or equal to. All right, moving on to the second problem. This one, we need to rearrange some things so that it's in a mx plus b format. So if I subtract my 2x, I'd get negative y greater than negative 2x plus 3, but I need to get y by itself, so I'm going to divide by a negative. Remember, when we're working with inequality symbols, dividing by a negative is going to switch the sign. So dividing by the negative here will then make it y is less than positive 2x minus 3. And so now that it's in the right format, I can go ahead and plot that line. And this time, because it's just a less than symbol, I am going to use a dashed line and not a solid line. And so here is the line. Because it's less than, again, I'm going to shade underneath the line. And so here, a solution might be something like 3, 0. And not a solution could be something like 0, 3. Okay. Or like I said, anything along that line because it's not included. All right, so that's just a quick recap. So now we're going to get to the actual system of inequalities. These are just one inequality on its own. So now we're going to deal with the whole system of them. So we're going to graph them individually, just like normal. Okay, So we have y is greater than negative 2x minus 5. It is in the mx plus b format, slope-intercept, so that's great. I can have that y-intercept at negative 5, so negative 1, 2, 3, 4, 5. Here it is down here. And a negative 2 slope, so instead of going down to right 1, I will go up to left 1. And this is going to be a dashed line because it's just a greater than symbol. And so here I am. Now, you have a couple options at this point. You can go ahead and do your shading now and then just kind of keep track of maybe the darkest shaded region, or looking at different colors, or shade some and then erase as you go. Some people like to draw all their lines and then go back and do the shading. It's kind of up to you. What I'm going to do for this first one is I'm going to go ahead and use different colors. So this first line, I'm going to use the same color as the highlighter. And I'm going to shade everything above. So that would be anything above this line would be possibly part of the solution. Okay. So here we are. So then I'll change colors. So maybe I'll use navy this next time. And I'll use the second. I'll go to the second one. So this one is going to be y is less than or equal to x plus 3. It's in the slope-intercept format, so positive 3, positive x. And so this one is going to be a solid line, and it's going to be shaded below. So that means everything below this line will be shaded. So right now I already know that my shaded region is, my answer to the solution is confined to the region that has blue and that orange color highlighted. So this right here, this area, is totally off limits. This right here, totally off limits because it doesn't have both of the colors shaded, okay? And then lastly, maybe I'll go with red, okay? So last I'll go with red. We have y is greater than or equal to x minus 2. Again, it's in the correct format that we want. Minus 2, positive x slope. So it is going to be parallel to that navy line. It's also going to be another solid line because it's a greater than or equal to. And so because it's greater than, I'm going to shade above that line. So everything above that line gets shaded. So that means the answer to my solution set is the shaded region where the orange, the blue, and the red overlap, which is right in between those lines and above that dash line. So I understand that this is going to be hard for some of you. So that means maybe you want to graph all your lines first and then shade where they all overlap. It just depends. It's a personal preference. I typically shade after everything is graphed unless I'm using these colors, or maybe whenever you, let's say like when you highlight and then highlight again and then highlight again, you notice it'll be the darkest shade. So that might be helpful too for some of you. But our solution is in that area where the black is. And so like if I do like this, that's where our solution is. So giving a point that is a solution could be 0, 0. Or origin is in the solution. And something that is not a solution would be anything not in that region. So maybe we're going with, let's see, 1, 2, 3, 4, 4, negative 4. Okay. So then moving into the second system, same process. This time I'm seeing immediately that I'm going to have to convert some of these inequalities into slope-intercept form to make my life easier when I'm graphing. So I'm going to go ahead and get started with this first one. I know that I would have to subtract the 2x and then divide by 3. Dividing by a positive 3 is not going to change my sign. So that's going to end up being y is less than. That would be negative 2/3 x plus 2. I subtracted the 2x and then I divided everything by 3. So I'm going to go ahead and graph that one right now. So positive 2, negative 2/3. So I can go up to left 3, down to right 3. And that is going to be a dashed line. And I'm going to go ahead and hold off on the shading for now to give you an idea of what this process would look like. Okay, so that was my blue one. So then I'll go ahead and still change colors because I like to do that. The second one is ready to go. It is in the correct format, so I can go ahead and start at my +4 and then use my -2/3 slope. Notice that -2/3 has the same slope as my first equation. So I'm going down to right 3 or up to left 3. Now this time it is a solid line. And I would technically be shading above, whereas the first one I would have been shading below. So that's also something to keep in mind. So for the blue, I would have been shading below, and for the green, I'm shading above. So as of right now, I would have had something like this and this. Interesting. Okay, so let's go to the third inequality. Let's go with pink. Again, I'm going to have to do some converting of that one as well. So all I need to do for that one is add the 2x over. So that's going to give me y is less than 2x minus 2. So that's pretty easy. Y-intercept of -2, +2 slope. And that one's going to be a dashed line as well. And that one, technically, I would have been shading below the pink line. So that would have been here in those regions, everything below that pink line. All right. And then the last one looks a little bit different. It's x is less than 4. X is less than 4. So that is going to be a vertical line. X is less than 4. So 1, 2, 3, 4. And that's going to be a dashed line. So we're here. And so let's see what we have. I'll use gray. Y was, for the first one, for the blue, y is less than -2/3 x plus 2. So everything below the blue line. Y is greater than the -2/3 x plus 4. Everything above the green line. Y is less than 2x minus 2, so everything below the pink line. And then x is less than 4, so everything to the left of the orange line. So technically here and here. Because they don't all overlap, then that means no solution. They all have to overlap at one point. So really, when we did our first two, the blue and the green, and we had what looked like this up here and the blue down here, that was our red flag right then and there. Those two things are never going to overlap. Therefore, there will be no solution. Okay, so in example 1, I gave you the system, you graphed it. And so in example 2, I give you the graph and you are going to write the system of inequalities. Okay, sometimes this is easier than graphing. So I typically work from left to right, or just whatever line I see is easier to start with. There's really no right or wrong way to do this. What I will do is I will kind of number as I go. So I have a system, and in my first graph, I see that I have 3 different lines. One of them is a vertical line, so I know that's going to be x is either less than or equal to, greater than or equal to. I know it's going to be a less than or equal to or greater than or equal to because it's a solid line. And so if I look at my shading, I notice my shading is to the right of that vertical line. So now I know it's going to be a greater than or equal to, and then it's going through the point -3, or the x value of -3. So there's the first one done. I'm going to go ahead and knock out this one next. So that's a negative slope and it's a dashed line. So I know it's either going to be a less than or a greater than. So y, and then I know it's less than because it's shaded beneath the line. So y is less than. I see that it has a -1/2 slope. So -1/2 x. And then it has a +1 y-intercept. So y is less than -1/2 x plus 1. And then the last one is this third one here. It is a dashed line, so it's going to be a greater than or a less than. It has a positive slope. So because it's shaded above the line, it's going to be y is greater than. My positive slope is 1/2. And then my y-intercept for this one is a -2. And there is my system of inequalities. Not too bad. When I move on to the second problem, I notice that I also have 3 lines. One of them is solid, the other 2 are dashed. So remember, it doesn't really matter where you begin. I'm going to go ahead and begin with that solid line. So I know that it's going to be a greater than or equal to because it's shaded above the line. So I know that's going to be y is greater than or equal to. And then I have a -1 slope, so negative x, and a positive 2 y-intercept, so negative x plus 2. Then I'll go to this line here. This has a positive slope. It's going to be greater than or less than because it's dashed. And because it's shaded to the right, it's going to be a greater than. I'm sorry, because it's shaded underneath, because it's shaded underneath, it's going to be a less than. It doesn't matter if it's on the left or the right. It matters if it's above or below. And technically that is below the line. So that's going to be a y is less than. That has a positive slope of 3. So it's going to be 3x. And it also has a positive y-intercept of 2. So that'll be y is less than 3x plus 2. And then our last line here, also going to be a greater than or a less than because it's a dashed line. The shaded region is above the line, so it's going to be a greater than. It does have a positive slope of 1/3, and it has a negative y-intercept of 1. And there you have that system. So I've given you a system and you've graphed it. I've given you a graph and you wrote the system. The last one is going to be a word problem, okay? So here we have our word problem. It says, let me find a pretty color. Let's go this one. You have $60 to spend on toys for Miss Baker's son. Stuffed animals cost $3 each and cars cost $2 each. You want to buy more cars than stuffed animals, but you want to buy a minimum of 4 stuffed animals. Write and graph a system of inequalities to represent the situation. So we have 2 variables that we're going to be dealing with. X and Y I'll use, and X, let's say X is going to represent the number of stuffed animals we buy. And then Y can represent the number of cars that we'll buy. Okay, let me make that a little bit smaller. All right, so those are the 2 things that we are representing. So X is the number of stuffed animals and Y is the number of cars. So one thing we know is that we have $60 to spend. We know the cost of each stuffed animal is 3 and the cost of each car is 2. So that means $3 for every X plus $2 for every Y, and we have $60 to spend. So this amount, $3 for every stuffed animal and $2 for every car, needs to be less than or equal to 60. I can spend all $60 if I want. I just can't spend more than 60. So anything less than or equal to 60 is good. So there's one of our inequalities. We also know that we want to buy more cars than stuffed animals. So that means cars, we want to buy more cars than stuffed animals. So that means stuffed animals needs to be, or cars needs to be more than stuffed animals. Why am I having a glitch right now? You want to buy more cars than stuffed animals. So cars needs to be greater than, oh, I'm looking at the wrong variables. Duh. Cars needs to be more than stuffed animals. Whew. All right, there we go. So Y is greater than X. And then lastly, you want to buy a minimum of 4 stuffed animals. So stuffed animals is X. X needs to be greater than or equal to 4, because a minimum of 4 means I could have 4 or anything more than that, right? So the number of stuffed animals could be 4 or anything more. So here is our system of 3 inequalities. And so we start graphing. I can work from the bottom because X is greater than or equal to 4 is going to be pretty easy. I'll go ahead and, knowing that I have this equation here, I'm going to have to rewrite it. I'm going to go ahead and count by 2's on my X and Y. So this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. This will be 28. And then I can do the same thing up here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay. So there we are. So remember, animals is X, and then cars, animals. All right, so X is greater than or equal to 4. So here's 4, solid line. So because it's greater than, I'm shading to the right. I also have Y is greater than X. So that means it has a y-intercept of 0, slope of positive 1. It's going to be a dashed line. And I would be shading above. Okay, so I'm shading to the right of the solid vertical line and above this dashed line. So far I'm in this region. Okay. And then lastly, I have this top equation that I need, or inequality that I need to kind of rewrite. So I'm going to subtract my 3x, so that'll give me 2y is less than or equal to negative 3x plus 60. And then I divide everything by a positive 2, so it doesn't change my sign. And that'll get me the negative 3 halves x plus 30. And so I know that still doesn't fit on my graph, but I really don't need it up there. So starting at 30 and then using a negative 3 over 2. So starting at 30 and then down 3 over 2 or down 6 over 4. So down 2, 4, 6, boom, 2, 4, 6, boom, 2, 4, 6, boom, 2, 4, 6, boom, 2, boom. All right, so there it is. And that one is going to be a solid line. And that one is shaded below. Its y is less than or equal to. So if I'm shading to the right of the vertical line, above the dashed line, and below the solid line that we just drew, that means I'm in this region right here. That's my sweet spot. Okay. So it says give 3 examples of solutions to the system. So that just means you could pick any 3 points in this blue area, and that could be solutions to the system. So let's say I pick the point 6, 8. So that means we could buy 6 animals and 8 cars, because that's 6, 8 is right here. I could pick 10, 12. 10, 12 would be right here. So that means I could have 10 animals and 12 cars. Okay, you're picking any solution in that shaded region and then just converting it to what it's actually representing instead of just leaving it as 6, 8. Well, what does that mean? That means I'm buying 6 animals and 8 cars. Another one could be, it could be 4, 6. It could be 4, 18. It could be whatever. Anything on that vertical line is fine. Anything on this solid line right here is fine as well, as long as it's not on the dashed line down here. So maybe we want to buy 4 animals and 6 cars. We could do that. Okay, so then C is asking, would you be able to buy 9 cars and 12 stuffed animals? Well, be careful, because cars is Y and animals is X. So really, that's the ordered pair of 12, 9. And if we look on our graph, 12, 9 is not in that shaded region. So no, we can't. And then just Don't buy Miss Baker's son any toys. He already has too many. So just don't even have to worry about that. So anyways, there you have it. You have given the system, graph it, given the graph, write the system, given a word problem, create your own system and graph it to determine your solutions. That's it. Bye.